Alright, in this problem, we're given the inductance of an inductor, and we're given the oscillation frequency of the circuit, and we're simply looking for the capacitance of the capacitor in that circuit. Now, fortunately, this problem is actually fairly simple. This chapter of the textbook, or this section specifically, already gives us a derivation for a very simple formula we can use that gives us the relationship between the capacitance, the inductance, and the angular frequency of that circuit. And I'll write down the formula here. And this is what that formula is. It's that the angular frequency is equal to 1 divided by the square root of the inductance times the capacitance. Now this formula is all we really need, except we'll just need to algebraically solve it so that it's an equation that we can use to solve for the capacitance. So first, let's get the capacitance in the numerator by multiplying both sides of the equation by the square root of LC. Just like that. And now we want to get the C outside of this square root, so we can just square both sides of the equation now. Of course, 1 squared is still 1, so that side of the equation hasn't changed visually. But now we've got the C in its own term. In order to get the C completely on its own, we just need to divide both sides of the equation by omega squared L. So the final equation we'll need to use tells us that the capacitance within the circuit, the capacitance that we need to connect, is equal to 1 divided by omega squared, the square of the angular frequency, times L, the inductance. Now the problem doesn't give us angular frequency, it only gives us the standard, the linear frequency. But that's not too big of a deal or anything, because we should know by now from previous experiments and problems that the angular frequency is equal to 2 times pi times the standard frequency. So we can just put that in for omega. And this is basically it. That's basically the equation we'll want to use. All that's left is for us to take the givens that the problem gives us and put them in for f. So 3.5 kilohertz in for the frequency, but we'll need to, we still want to get these numbers into SI units, so we'll want to convert from kilohertz into standard hertz by taking 3.50 and multiplying it by 10 to the third power. Same for the inductance. L we want to substitute in for the inductance that the problem gives us, 1.30 millihenries, and we'll take that 1.30 and multiply it by 10 to the power of negative 3. If you were to plug this into your calculator, you'll get an answer that is something along the lines of 1.59, and I say something along the lines of, but that's just because I'm rounding to the proper significant figures, and you'd get this times 10 to the negative 6 farads. And of course, it's standard. By convention, we typically write out capacitance in terms of microfarads. So we just want to multiply this answer by 10 to the power of positive 6, which fundamentally all that really does is it's just going to remove this term entirely. So in the end, we are able to write our final answer as 1.59 microfarads. And that is the solution to this problem. I hope this video helped you out. If you have any questions, please do not hesitate to post a comment down below, and I would be glad to help you out. If you'd like to contact me for requests on future videos to do, I have a Discord server that is linked in both the video description and the channel description, should anything happen to the current link. And that is all for this video. So thank you very much for watching.